Okay, so in this video, we are going to draw a square, and it sounds simple. It kind of is, but we're used to drawing squares just like merp, 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 merp. But how do you tell a computer how to draw a square? So there are steps that you should take before coding, okay? First, you want to think of an algorithm. Next, you want to write out some pseudocode so that when you go to write your actual code, you have a really good idea of what you're planning to do here. So let's create the algorithm first. What we're going to do is we'll make like a numbered list. And this will be like the steps that we want to take to solve this problem. So to draw a square, you have to draw a side, right? But in an algorithm, we also need to be very specific. So we should probably give a length of that side. So I'm going to say, draw a side length of 50. Okay, this can be any number. This is just an example. Then what you can do is, so after you draw a side, right? How do you know how to draw the next side of the square? Well, you're actually turning 90 degrees and then drawing that next line. So what we're going to have here is turn 90 degrees. Okay? Then we will repeat steps 1 and 2 4 times. Okay? And that's how we draw a square. It's a very simple algorithm. Okay? Now let's write the pseudocode for this. So our pseudocode will look something like this. Let's think about what we'll need in Scratch. So we definitely need an event to trigger this square to start. So I'm going to say when the S key is pressed, okay? That'll be our first block. Then the next part of my pseudocode might have a move, or we need to access the pen so we can see the square. Okay, so yesterday I introduced the pen palette in Scratch, so we're going to use that. So there's so you want the pen to be down on the paper. There's a pen up and a pen down. So you want the pen down when we're drawing, okay? So I'm going to say pen down here. Then we're going to move 50. So that pen is drawing as we're moving 50 steps. Okay, so move 50. We're thinking about the blocks in Scratch because it's a pseudocode, so we want this to be close to what the blocks will say and look like. An algorithm is more of the series of steps that we need to take to accomplish this. And pseudocode is more of, okay, what's the code actually going to look like here without actually writing the code. So we're going to move 50. Then we want to turn 90 degrees. And then we'll move 50, turn 90 degrees, move 50, turn 90 degrees, and move 50 again. And that gives us our 4 sides of the square. So then at the end of that, we want to put our pen up, okay? Because if we don't put our pen back up and we start drawing something else, then that pen is going to drag, and we don't want that to happen. So let's end our square with the pen up, okay? So now, let's use our pseudocode to create this in Scratch, okay? So we said we're going to go to our Events tab, and when the S key is pressed, okay, let's grab our pen palette. When the S key is pressed, let's put our pen down. We're going to move 50 steps and turn 90 degrees. Okay? And then let's duplicate that. Duplicate that. I'm just right-clicking to duplicate. And then at the very end, we're going to put our pen up. Okay? So let's push the S key. Looks like it made a square. However, I'm going to change some things, okay? Because this was updating as we were drawing it. So let's add some stuff. I would like to put erase all at the beginning because it erases everything that is currently on the screen. Okay? I'm also going to put in a starting point for my sprite. So the canvas is like a coordinate grid where the center is 0, 0. And that's actually where I would like my sprite to start. So everything on the canvas will be erased. We're going to start in the center and then draw this square. So I'm going to click the S key one more time and see how this turns out. Looks exactly the same, but so that we can see the difference, I erased everything. Bam. Okay, so I could keep drawing squares in different areas. And that's a square.